When we have something with a constant rate of change, we can graph it, and the graph of that thing that we're measuring will have what is called a linear graph. And a linear graph is called a linear graph because it makes a straight line. And in fact, the word line is in the word linear. It's a straight line. And that is what a graph of something with a constant rate of change looks like. And we can find the rate of change of a graph by measuring what is called the rise and the run of a graph. And the way that you measure rise and run is really simple. You pick any 2 points on that graph and you count to get from one point to the other how many times or how many spots on that graph do I have to go up and how many spots on the graph do I have to go over? And so how many spots you have to go up or down is the rise, and how many spots I go to the left or right is the run. So in this case, the 2 points that we're using are this point right here and this point right here. And so whenever we count the rise and the rise is right here, and we're literally counting the squares. So this is 1 square and this is 2 squares. And so the rise here is 2. And we do the same thing for the run. We count squares for the run. So this is 1 square, 2 squares, 3 squares. So the run here is 3. So it looks like our rise is 2 and our run is 3. And the way that we find rate of change, which is also called slope or rate of change, is rise over run. It is the change in the y coordinate, the up and down, over the change in x, which is the left and right. So it looks like the rise over run here is 2 over 3. The rise is 2 and the run is 3. But this line actually has a negative rate of change. The slope of this line is negative 2/3. Okay, how do I know that this line is negative 2/3 and not positive 2/3? Well, the answer is the direction that the line is going. This line is going down. This line is traveling downward. Okay, well, how do I know that this line's going down? Like if I go the other direction, isn't the line going up? Well, we read graphs the same way that we would read a book. We read it from left to right. So if I start on the left side of this graph and I read it going to the right, so I read it going in this direction, the graph is going down as I go from the left to the right, so it has a negative slope. The other way that you can tell that this line has a negative slope or a negative rate of change is that the rise is going down as well if I read from left to right. So the run, I count over 1, 2, 3, but then the rise, I have to go down 2 spots. Again, if I read the graph from left to right. If I read from left to right, I'm going down for the run instead of up. So that's another way I can tell that this particular line would have a negative rate of change or a negative slope. Well, what if I hadn't picked those 2 points? What if I had picked two different points on the graph? Well, let's see what would have happened then. Let's pick the origin. That seems like a pretty good point. And let's pick another point on the graph. Now, you can pick any 2 points on the graph that you want to. So I could, for example, pick this point right here. But if I zoom in here, I think you can see why picking this point would not be a very good idea. What are the coordinates of that point? I mean, like it's in the middle somewhere, so is it a half? Would that be like a 0.5? Maybe it's 0.5, maybe it's 0.6. I don't know. I can't tell exactly where that point is because it's sort of in the middle of the grid. So although I could pick that point, I probably don't want to because it's difficult to tell where exactly that point is. So instead, I want to pick a point that it's really easy to tell where the coordinate is. So I'm going to pick this point right here because that point is exactly on the intersection of that grid. So it's really easy for me to tell where that point is. It's really easy for me to find the coordinate. Okay, so now I'm going to count the rise over run, reading from left to right. So I'm going to start with this point right up here at the top. That's going to be my first point. And I'm going to end with this point because I'm going to read the graph left to right. So let's just count how many squares I have to count over. I'm going to go this way and then this way. That's going to be my rise over run. Okay, so let's count. I'm going to go 1, 2, 3 squares. That's going to be my run. My run is 3. And then my rise is 1, 2. That's my rise. But because my rise is going down, it's actually going to be -2. So my rise over run is going to be -2/3, -2/3, or -2/3. So even though I picked two different points that time, I still ended up with the same slope or the same rate of change. So as you can see, it doesn't matter which 2 points you pick, I will get the same rate of change every single time. So if I can pick any 2 points, the 2 points that I want to pick are 2 points where it's really easy to see where the coordinates are, and that's usually going to be 2 points that are on the intersection of the grid, so that it's really easy just to count the number of squares in between the 2 points.